Hello again from Skip, Victor Echo 6 Bravo Golf Tango. Well, I can't believe I have another IFR story to tell you. I wasn't going to make a video of this because it's just another IFR, but oh, believe me, this one has a unique twist to it and a very unique problem. And I did some head bashing, so I think you'll enjoy it. So when I was given this thing to look at, I took the covers off it because it was dead, more or less. It kind of lit up a little bit, but something was seriously wrong, and the power supply, it was squealing like a pig, like a stuck pig. I've never heard a power supply howl like that, and it was making a terrible noise. And I wanted to get my voltmeter and have a look at the measurements. The voltages come out of this thing, and before I knew it, there was smoke curling out of the top of the faceplate like crazy. Not from the power supply, just from out of the top of the power supply the faceplate. And oh yeah, it was a lot of smoke, so that's when I shut everything off right at that moment. I knew that something was up. Well, it looked like this thing was going to have a lot of issues, like most IFRs. So where to start? I thought, well, I'll pull the power supply out first and have a look at that because that's what I'm kind of used to. So again, this is the power supply. Just like in the other videos, I'm not going to get into it right now, but it has a weird problem. And what I really wanted to get into is see where the smoke was coming from, because there's nothing in here that was smoking. No traces of anything burnt or black. Usually there's a good smut mark in there somewhere, but absolutely nothing. So I started pulling the boards out at the top of the unit first because, there was a lot of smoke. Nothing's going to smoke that much and not leave a mark. So I figured, well, we'll tear the boards off first and see if there's a tantalum or something that went up in smoke. But nothing. It was just totally bare. Couldn't believe it. So I was still on the hunt for the illustrious smoke. I took the front panel off and started looking real close here and there, and underneath the chassis where the panel was and all that, and nothing. Couldn't find nothing. So I was still on the hunt. So I just about missed it, but if you look at the faceplate there, like this the picture I had on here before, if you look down on that faceplate, just left of the green circuit board, you can see a little black mark there. And like I said, I did not see it at first, so that's where it was. Under closer scrutiny, you can just see a little resistor underneath that board. And amazing how such a small part could smoke so much, because it was bad. But anyways, there it was. So now to take it apart a little farther. So this is a new area for me. I've never had an IFR panel tore apart like this, and it comes out in one nice big module. And you can see the fluorescent display there, and that nice little resistor that's fried to a crisp on the board there. Well, looking at the maintenance manual, it looks like it's an afterthought, all right. It looks like they've taken the foil and cut it, then added this resistor, R13. So, interesting. So looking at the schematic, R13, it's a 12 ohm resistor. It is connected to the negative 12 volt rail, which I'll be fighting with later. Anyways, so what's shorted out? But then you look across and, C12, 150 microfarad. I bet you it's another one of those cursed tantalum capacitors. Well, definitely looks like an afterthought. It looks like it's piggybacked right on top of the crazy chip. It's not even on the board itself. Weird. Yeah, it's one of those things. Sure enough, it's a big, ugly yellow tantalum piggybacked right on top of that chip right up there in the top right-hand side. And it's a tantalum. Big surprise. So I'll see if I can get this capacitor off here without too much difficulty. It's just piggybacked across the length of this chip, so it should be relatively easy to just tab on there. Yep. Yep. Well, we'll see if this thing's any good. Get my little handy dandy capacitance checker. I'd love this thing. It's cheap and all that, but hey, it works. Everybody has one of these, I'm sure. Let's see. It's 12 ohms. It's like the resistor just burnt out. I'd say this tantalum is a typical tantalum shorted out. Can you see that? Yeah, you can see that. Yeah, that's crazy. Well, that's what caused all this. Interesting. So I'll get the capacitor replaced, and then I changed it, pulled the old burnt resistor off, and cleaned up the burnt board the best could, and put on a new resistor. And since I had it all apart, I figured, well, I'll take some Windex and clean the push buttons that are on the front panel. They were getting kind of grimy. So got all that, got to start and put things back together, and the board was all put together. Time to reassemble it a bit. So got all the buttons in, the capacitor and the resistor. So nice fancy fluorescent display. So that's going to go in here like so. Get that wire out of the way. Yeah, like that. Put in a few screws. Ground clamp. Oops. I knew that was going to happen. Pretty. Just like so. Buttons are all nicely lined up. She's a put together panel. Slowly. Still got to put the power supply back together in here, but oh well, we'll get it. So I figured it'd be a straightforward fix, just like all the other power supplies have repaired on these IFRs. But oh boy, this is when the fun started. I'll tell you. So as before, I got the power supply module out of the chassis and I split it in half. Got the main inverter board from inside the metal box, and did the usual changing the electrolytics because they were all leaking, an ugly looking mess. So that's where it started. And as I tested things, I would fire it up and measure voltages, find out I'd still have a short, and I realized that the goo from the capacitors had leaked underneath these inductors and corroded the board really nice there, and even farther up the circuit board underneath the two switching transistors for the main inverter. It was a horrible mess. It finally started to work, no more shorts, and then I had to contend with this. So I got the power supply running, but it does something different than the other ones, and I don't think it's supposed to do this. I mean, it's regulating and all that. Let's listen to it when I started here. Oh, let me put the power on. There we go. A little squeal. Okay, I'm used to inverters hearing that. But now this is with about 18 volts going into it. This machine was to run off external 12 volt battery. There's 15 volts. It's still regulating at 12 volts on the output, but it's oscillating like crazy. It's transforming. Yeah, the FET's getting hot. I've already replaced this one capacitor, and it didn't seem to do any good. So I'm not going to leave it. I'm going to keep looking into this. I'm kind of curious what causing this thing to oscillate. I got to look at a scope on here. I might even change this switching FET for the fun of it. But very strange. Low voltage like that, it doesn't want to start all that well either. I'll start it again. There's squealing it. Regulating it properly, but yeah, crazy anyways. Stupid thing. Yeah, I thought I'd record on a scope here what this oscillator looks like too, just before I change things. And See if there's a huge difference. So we're going to start it. And you can see the bit. I'll zoom in here a bit. See the mess. It's not going to lock up very well. No, too much crap. Now when I turn this down, let's see what it does. I don't know. Definitely steadier when it's higher voltage. But I don't remember seeing a double hump in there and all that. There's something not right with this switching. Huh, weird. Yeah. Like tuning an old radio. Oh well. So this is the whole power supply, the inverter section of it anyways. I'm going to try and, oh boy, explain just part by part briefly, just so you can understand what I'm looking at here to fix this thing. It's not that complicated, just you got to look at it in sections, that's all. This is the first section we deal with. This is the main oscillator. It's a little op amp that has feedback, and it just creates a kind of a trapezoidal 47 kilohertz oscillator. The oscillator is fed into this next op amp, which is a simple comparator circuit. Just above the oscillator, the main oscillator, there's two Zener diodes, and this sets up a 10 volt and a 6.9 voltage reference circuit. Op amp to the right of the Zeners is another comparator circuit, and it's what takes feedback from the 12 volt output from the transformer, and with one of the references sets up the regulation circuit. Here you can see the main switching FET, and it's simply taking the oscillator circuit that's controlled by the references and the 12 volt feedback and switches the primary of the inverter transformer to give us the end result of the output voltages plus 12, minus 12, and 40 volts. And finally at the end, the separate circuit which produces a plus 5 volts for all the we'll call it logic circuits, I guess, and chips and stuff like that. Well, the first thing I did was check these references, these standards. There's a 10 volt one and a 6.9 volt, and with voltmeter it looked fine, but when I put the scope on it is what clued me in. Okay, I'm still trying to figure out why this thing is acting kind of strange, this oscillation. I don't know, it just, it works, but I don't think it's supposed to be doing this, so I'm going to show you something. I'll zoom in here a little closer. This is the, fire up the oscillator here. Here we. Oh, I'll turn this on here. This on here. Now, there's a 6.9 volt Zener that is used as a reference in this integrator op amp, and I'm seeing this double pulse coming off this darn thing, and that shouldn't be there, I don't think. And that, of course, is going to get mixed in with my other signal, the actual oscillator signal, and then give me this looking mess. This is what's driving the transformer. So you see the double pulse there. So I can see why that double one there gets mixed in with it, because it's using this voltage in the I think the inverted input of the op amp, and that's not supposed to be there. I don't think, anyway. So I'm going to keep looking. Sure enough, another capacitor, this time a real small one, just 47 microfarads, but it sits there between those two Zener diodes. And of course it leaked all over the board and made a mess of things, but it made all the difference in the world when I got a good one in there. Well, 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 I think I've got this stupid power supply finally fixed. Watch this. Okay, it's hooked up there. I got to engage the enable line. Just a little squeak there, nothing to speak of though. So it's putting out. There's the regulator side of it is 12.2 volts, which is a little higher, by the way. So this is indication also. Now, I'll go back up to the scope. And I'll show you what I've got going here. Let me zoom in a bit. Okay. Okay, I'm going to get the scope lead hooked up. First, I'm going to show you that I think it's 6.9 Yeah, 6.9 volt source. I was seeing that double pulse on there. Look at that. It's perfectly clean. Your snares down. I got the ground level down to the bottom because it's just going to jump up. And roughly 6 on 2 volts per square there. So 2, 4, 6, 8. Yeah, 6.9. Say so. So that pulse is gone. Now watch when I go over to the chopper, the what do you call it, the driver set for the transformer. And look how nice this looks. Way better. This is what I'm used to seeing. Perfect. Let's go on here. Let's put on some stuff. Time, frequency. 47 kilohertz, exactly what it's supposed to be. I mean, I can't get nicer than that. So now when I, what I'm going to be doing now, let's see if I'll show you here. I'm going to be adjusting the power supply. This is what I'm feeding into, about 18 volts. It's usually around from 18 to 24. Now, before, when I turned this down, and I got right around there, it was just squeal like a pig. And it's perfectly quiet. And the drive pulse is perfect. Oh man, I can't believe it. And all it was that one little capacitor in there that I replaced, which was a filter on the 6.9 volt source, Zener source. That capacitor was wide open. And it had leaked a little bit of crap out too. I changed other electrolytics in here too, just for the fun of it, because it was just, I mean, this thing's just crazy with bad capacitors. So that capacitor was right in, I'm using a metal lead, isn't that great? This one right here. This filter I changed too, because it was looking not great. It's just a filter on a 5 volt line off the multi-vibrator for it. So that one did it. It made all the difference in the world. So I think I might have her built. You never know. We shall see. Okay, before I package this thing up, I thought I'd just show you a few waveforms here, and then I'll try and relate them to the schematic also here in the video. So we're looking at the power supply here, and I'm going to enable it. And there it goes. No squeal. That's a nice sign. So we got 12. Whoops, didn't want to do that. Got 12 volts on the regulated output. So, okay, so what we're going to look at is the 10 volt source, reference source, and that's what I was getting that double pulse on I was showing you before. It's the same as it feeds over through a resistor to the 6.9 volt Zener, which is also a different reference point. Oh yeah, so I'm going to go on top of this transistor right here, and that's where that source is connected to. So we'll swing up to the scope here so you can see what I'm doing. Just looking down there is nothing. I'll zoom in a little bit. Let's try this. Whoops. There we go. Let's try that. Nothing but fingers here. Okay. So here's the source. Now we're on DC. Let's get some more things going here. Voltage RMS. I think that's what I want. So the frequency and voltage being displayed here. So I'll click on there. And we got 9.8 volts, which is 2, 4, 6, 8, 10. Yeah, so there we go. And no pulsing whatsoever, so that's good. Now I'm going to go on the comparator circuit. It's what compares this reference voltage to the feedback from the 12 volt supply. So pin 2, so U3, pin 2 is the reference. That's this one here. And looking at 5.26 volts, and it's the 6.9. It goes through a resistor, through some resistors, so that's the reference, but it's clean. Before I had that pulsing in there. Now the input, the feedback from the inverter circuit that's regulating all this, is pin 3. There, nothing. Looks darn good. We're looking at 5.26 volts. This being stepped down through voltages. This is where the trim pot is to adjust the 12 volts output. Nice and clean. A little bit of the ripple there, maybe. Real small. Now, if I go on the output of this with pin 6, 4, 5, 6. And we got some rough. We got a little bit of bumps going on there, and that's what's, controlling it all. 47 kilohertz and 1.8 volts, roughly DC. So that's looking better. Now, just to show you the oscillator circuit that this thing controls is this one over here. You 2-pin, 1, 2, 3. Here's the square wave of it all. And, well, trapezoid, I guess you call it. So this is one of the inputs, and then the other input is that other little noise we had from the other comparator circuit, and that's what controls it all. And 47.9 hertz. Now I'll go over to the oscillator. Gotta knock the voltage down, and there it is. Yeah, 18.9 volts, 47 hertz. And if I play the voltage, no squealing. You just see it adjust here and there. So life is good. I think we got it built. Another fun circuit anyways, crazy thing. So get it all boxed up next, see what happens. Well, get the power supply put back together and back in the chassis, get the faceplate mounted, and see what happens. I was feeling pretty cocky. I shouldn't have been. So this is the next part to getting this faceplate back on. It's a bit of a trick. It's not too bad though, but it can be done. Like this. And let's see, I'll move the camera a bit because that's where we're going to be concerned. Here. Okay. I'm trying to remember how this all works here. That goes like so. And cord. The biggest thing I've got to remember to do first is this ribbon cable's got to plug into the board. That's the first one. Oh. Jeez. Not exactly a lot of room. Think there'd be an easier way, wouldn't you? Hope I can bend it over. Done this before now. Come on, there's much trouble. Oh, here we go. I think. There we go. There she's plugged in. Yeah, that goes to the motherboard so that one I can lay it down. That. This cable over here. This side here has to put all these SMA connectors here. That goes there, that one there. I think. Like that. Yeah, we're good there. Ribbon cables hooking up. Behind the board. Try that. That's the main connector here. Still something holding us up here. I'm not sure what. Oh, there we go. No, just gonna press it in. Oh, on the top side. Oh, that's the main connector we got up here. Get pinched. Oh, you stupid thing. Anyways, it's going to be fun, so I'm not going to bore you with the details here. I'll stop the video here. Okay, I got the faceplate bolted on finally. I didn't want to bore you with that. It took a bit of doing. There was a connector that was wrapped up underneath that I didn't get done. So I got the two ribbon cables plugged in there. I don't know if you can see that or not, but that part's done. It's a bit tricky also. So, next is all the other wiggly connectors. And which one was it? This little brown guy here. I think it's the power switch. It's the one that was holding me up, and it's going to be dicey. It's way around the corner there. These all go on boards that come in later. But basically now I'm going to do up these SMA connectors here for all the different connections from the, well, two of them here from the, I think, hold the jack. What do we got? Yeah, we got some video here. I should zoom in a bit. So there's a pile. The step attenuator, this one here is the duplex power out. It goes into this position. Of course, there's just not enough room to get my fingers in here. But I'll get these started with my little wrench. And then there's this one here on this. There's an SMA jack that's underneath these cables. Good thing you're robust little fellas. And then this one here. Come on. Start up. There she goes, I think. And this one tucks up underneath the board. It's got to go in there underneath that. And then I'll tighten up, there's a few more cables. One connector, here's a ribbon cable here, goes in there. And yeah, get the power supply in it after I get all this done up, and then we'll carry on for more testing. That'll be the moment. I'll have to get the circuit boards put in too, so we'll get to that. So I've got the inverter board back inside the little tin box and reassembled. There's some more testing on it. Got it back into the chassis and bolted down, and so far so good. So this is next, is getting the circuit boards back into the card cage up in this little area right here. I checked the darn memory battery on the CPU card, and it's dead, of course, so that's one I'll probably replace. But for now, I'm not going to worry about it. I want to get the things in here and see if it comes to life. Because it had some horsepower problems, and then that other board on the display was going up in smoke. So interface card first, CPU card. I don't remember what that one is. Anyways, it doesn't matter. I got them in order. I'll make sure they fit in right, and then it'll be testing. Oh boy, excitement. Yeah, anyways, slowly getting these boards all together. Like this. The next one is the receive audio. Well, I know this board very well. There's a jack on this one now. I've got to find it. It goes down to the bottom here. It's a mystery one on the other units. Wiggle it in place. And last but not least is the generator audio, I think it's called. And it goes like so. Anyways, there we go. Hook up the rest of these ribbon cables into the modules, and almost ready to try something scary. So, got all the boards plugged in. I guess this is the moment of truth. So we'll set this thing up here. I'll do this here a little better maybe. Okay, let's put an antenna on this. Oh, we got an antenna here. Where the hell did it go? There it is. A rubber ducky. I'm thinking positive here. Oh, that BNC connector's got a bit bent. Okay. Plug it in. check some power supply voltages once it fires up. So let's get this down here, and let's get this over here. Well, I should check and see if you're seeing anything here. All right, well, we'll try it. Actually, let's see if you can spot anything here, maybe. Well, okay, here goes nothing. Oh, this is good. Oh, the display is kind of weak. Oh, it's in general. Let's go to receive. Yeah, that's a bit, probably can't see it, but it's not very bright in here. What's going on here? Oh, I don't like that. Oh, I know why. Battery's dead. Yeah, anyways, can't spot it, but that's dim. It's not very bright, but it's dim. But hey, it's working. We've got squelch. Let's go to, oh, I know, I got a wide. Oh, let's do a wide. Let's go to our radio station here. Let's see, receiver program. 98.9, enter. Oh, hey, look at that. Oh, do something. You can see the spectrum analyzer is there. Turn it down a bit. Yeah, look at that. Okay, that's a good sign, but I'm a little concerned about the display. It's not very bright. Let's try generate. Oh, yeah. Okay, that's working. We got, let's go to narrow. We got 3 kilohertz up there, roughly, and 3 here, so it seems like it's working. Now, let's have a look at the voltages. I'm not a little concerned here about that display, because that was part of it that was smoking. Man, okay. At least I don't see any smoke curling out anywhere. That's a good sign. All right. See if I can get this all in the same display so you guys can see this darn thing. Okay, first we're going to check the, see how's this working here. It goes like this, it's like this. E4 is the 5 volts, 5.1. That's good. Okay, next one is the 40 volt display for the scope. I think that's here. 39 volts, that's pretty close. That's the input from the AC supply, 24, yep, 24, as I've had before. Now this in here is the negative 12. Oh crap, negative 10. That's something to do with that display. Okay, what about the 12 volt regulated? And it's good. Oh well, we got something going on here. Negative 10. That should be negative 12. And that's why that display is kind of dim. Either this power supply is not putting out properly, or we still got a slight load and everything. But hey, it's working. That's something, anyways. So we shall carry on here and see what we can figure out. But it's coming. Stupid thing. Okay, that's it for this part. So it was back to the power supply. I spent a lot of time on this stupid thing, and I finally took my other IFR apart and pulled a power supply out of it and put it in the chassis to compare, and it worked beautifully. So there's something about this power supply and this bad one here, the weak 12 volts, and I tell you, I went around and around the circles figuring this one out. Okay, well, I had to share this with you. This is hilarious. So I made some custom little cables instead of soldering things on. Made little pin things so they'd slide on nice and neat and stuff like that. And, so it's just easier to hook things up, you know. So I'm ready to go here. I got my voltmeter set on it and all this, a different voltmeter. And when I first look for it is when I turn it on, when I plug in the power, I go like this. There should be a jump from the capacitors charging up. And I saw nothing. I figured, well, that's weird. Why nothing? So I got my voltmeter over here, and I'm looking around. There's just, absolutely nothing. I'm poking around, looking here and there, and I got nothing. I mean, I got voltage going in on this pin. There's, 19 volts going in, but there's just nothing coming out. It's just zipping. I'm scratching my head. Well, what's going on? Do you think this might have something to do with it? There's nothing in it. Bonehead. I got the wrong power supply. I want this one that has lots in it. Can you? Oh, I tell you, I have some days. some are doozies. Oh, well. No big deal. We'll get on to it yet. So I spent a lot of time on this thing trying to figure out just what the difference was, and I had the two power supplies side by side, and I was comparing the waveforms, and you can see the pulse width on the good one's wider than the bad one, and this and that, and it was a headbanger, I'll tell you. I pulled a few capacitors out and checked them, and pulled out some op amps, two comparator op amps, so I did see a little bit of out of their old capacitor ooze did leak underneath it, and so I got some new op amps in and tried that, but nothing was going to work. I was kind of pulling my hair out, what was left of it. So at this point, I was a little frustrated, needless to say, trying to think what next. I mean, I've done just about everything I can think of in this darn thing. I've replaced parts, I cleaned boards, I found some corrosion here and there, stuff like that. But you know what? I'm thinking, I don't know. You know what? And then I just did this. You know what? Wait a minute. Look at this. And then I started torquing the transformer back and forth, and it's all over the place. And I thought, what? So I immediately shut everything off, and figured, don't tell me it's going to be something simple as a stupid solder board connection. So I tore everything off and got underneath, and I took my soldering gun and I redid all the connections for the transformers. Transformer leads, on the inverter part, and tried this and that, and then I was warping the board and everything, and it was all over the place. And when I noticed I was putting a screwdriver inside, it was acting up. I thought, what in tarnation's doing that? And I thought, well, is it a transformer? I thought, it can't be, can it? Well, you're not going to believe this one. I should have went with my gut feeling at the very beginning, because I suspected it was this transformer. Watch this. I got to enable it here. Okay, this is the drive to the primary of this inverter transformer. Now, watch this action. Unreal. See the duty cycle change? That's the issue here. Now, what's happening? I'll see if I can show you or not. I'll go down. Find the darn thing. Here it is. This is the transformer. And what I'm doing is I found the whole top part of it's loose, if you can believe this. And it's just, it's the magnetism. If I go over to the voltmeter and look at the negative, it doesn't affect the 12 volts, it's just the negative. You can see the 12 volts regulated one, the negative one was 100. This should be, from other machines that I've played with now, it should be like 14, 15 volts. Watch this thing as I move this transformer around. Look at this. Oh, this one went to sleep on me. These fluke meters are always doing this. And this is what I saw at the beginning of this crazy. That's where it should be. It's right there. And I'm looking at the scope, and it's, you know, the duty cycle's way up. So I think I found it. Good grief! Talk about a grief. Yeah, I don't know how the hell I'm going to fix this so it stays permanent. Jeez, unreal. Oh well, such is the fun of working on a stupid IFRs. Thought I'd see if I could show you a close-up. You can see the crack. I've really loosened it up now. It wasn't like this before. You didn't see this. It was actually pretty tight. You see the crack there, and then if I get my fingers on there, and look at all this goo. It's like this thing has been leaking. You know, I got a sneaky feeling this thing's overheated or something, and the cement they used to hold this thing together oozed out, because I did clean some of that off the side, but it's definitely it won't come off. I can almost pry it off, but I don't want to force it. It might break something, and then I'll really be in trouble. Crazy darn thing, eh? It just blows my mind. It's something like, you know, I just, in the back of my mind, when I first started troubleshooting this thing, I thought, boy, it just acts like this transformer's not acting right. But, you know, I'm thinking, why isn't the 12 volt regulated coil not being affected? Well, it's being regulated by it's almost like a phase lock loop circuit. But I get a sneaky feeling too that there's different coil windings, and I think the 12 volt positive is on the bottom and the negative one's on the top, and that's where the core is mostly affecting it. I don't know what the construction of this thing is, but we're going to see if we can glue it together and then go from there. Wish me luck. Okay, I'm going to try this. I'm going to say I'm a little nervous. We shall see. I'm going to try and just dabble some of this crazy glue along the one crack here. See, this doesn't open up that much. I don't have much time. Try that. And here. Try that now. Fire it up. Get it adjusted. I'm going to hold it right there. Might have got it higher, but I don't know. This stuff sets up so bloody fast that. Oh, finger stuck. It's holding. I think I'll put a little bit more on it. Don't think it'll dissolve anything. Oh yeah, Dave was right. It wicks right along nicely. Yeah. I'm not gonna touch it. With any luck. Let's have a look at the scope for the fun of it. Waiting here. Curious. Yeah. I'll show you. Get on the scope. Got a bit of a light glare going on there. There. Now we'll move in. It's not 100, not 50% like I'd like to see, but I don't think I want to take any chances, so I'm going to try it. We shall see. Stupid thing. But, it's holding. It better do it. I don't know what I'll do after this. So it should be entertaining. Anyways, that's it for this part. So it's been half an hour, almost an hour. And let's see what it's doing. Get back. I guess the main thing to concentrate on is the voltmeters. You don't need to see me tapping things. Get the glare out of there. Okay. Re-enable it. Get the thing running. Look, Ma, 14 volts. Exactly what I've been looking for. So, the tap test. Ooh, like it so far. And move up and down. Oh. Hours and hours of troubleshooting and pulling what's left of my hair out, and there it was. All it was a stupid transformer. Should have my gut feeling in the first place. But whatever, it works out, so that's the main thing. So now I'll put it back together again. Well, it's back together, and we're going to try it out here. See if we can see things. Oops, that's not going to work. Let's put this over here. Hang on a second. Let's get a proper alligator clip on this thing. We can clip it over here out of the way. Oh, still got things in focus more or less, yeah. Oh, I'm gonna try things here. Oh yeah, of course, check some error, no battery in the computer, CPU card. And program RF 147.0. So far so good. And audio. The display looks a lot better. But I think we might be still lacking a little bit, but I don't know. I think without replacing that darn transformer, I don't know if there'd be much I can really do about it. I'm gonna have to call it good, I think. So here's the end result, if you can see it. I'm trying to keep my hands away here. This is the positive 12. It's a little high. I could turn that down, but if I do that, 0.1189. It's so close to negative 12, I'm not going to worry about it. One thing I do notice is if I, see, we're going to go on here. So audio's up. Voltage goes up. It's unregulated, so I think we're going to call it good. The other voltages are good here. We got 40 volts for the scope, and then negative 5 over here, 5.1. I could tweak that down just a touch maybe, but it's so close to negative 12, I'm not going to worry about it. I say without replacing that transformer or the whole power supply. Who knows? But it's back to working anyways. That's the important thing. So what are you going to do? Scope's working, everything's looking good, so I am going to call it good. Put her together and say c'est la vie for another one. Hopefully it'll last for a while. Man, I've been going through IFRs like crazy. Well, there it is. Turn the sound down here a bit. It's a bit loud. They're both running identical. Look, Ma, stereo. And the voltage is definitely better on this one. By a half volt, this one here is just floating at negative 12. With the positive up just a little bit higher. So, oh well, that's all we can do. Unless we can find a different power supply or something for this darn thing. But for the time being, it'll do. So I'm going to finish putting them together and call her good. So that's all there is for now. It's just an update. That thing running for about an hour now, and look at this. The voltage is way up. So I'm going to tweak it just down a bit. I guess things warm up a little bit, things change. bring this down so that he's not so high. Let's try right there. 12.17 there. And 12.41 there. You can go down a bit more, but yeah, I'll leave it there. Crazy damn thing. Anyways, there you go. So I was pretty happy. The IFR was running away there, and I was working on this video. And things were looking good and sounding good, and all of a sudden, I smelled something. A bad smell. I go over to the IFR, and it's dead in the water with a bad reek coming from it. I couldn't believe it. Will this thing ever end? Unreal. Anyway, so I went looking for the bad smell, and on the tone generator board, another tantalum head went up in smoke. So it was on the 12-volt line, so it probably got damaged from the previous power supply explosion. Boy, talk about a IFR from hell. No more IFRs, please, please. Go back to look at something more peaceful and calm and more relaxing, like a dish on a beautiful day. So if you made it through all this, thanks for watching. 73 from Skip, Victor Echo 6, Bravo, Golf, Tango.